Hi everyone, welcome to another video for the Reproducible Rehabilitation Research Education Program, or Repro Rehab. This is the third in our series of videos, and in today's video we're going to be talking about importing data, stitching individual data sets together into one larger data set, and then exporting that kind of merged data set to a separate file. So before we take a look at R, let's actually look in the GitHub repository for Repro Rehab. So this is, if you've downloaded my R crash course repository, you should have this saved somewhere on your machine. In my case, it's in the documents folder, right? Then under GitHub, then Repro Rehab. So the exact location on your machine might differ, but if you've forked this repository and then cloned it to your desktop somewhere, you'll have this Repro Rehab folder. Inside of that is the data subfolder, and then we're going to be working with some data today that are electroencephalography or EEG data files. So the individual subject files are in this folder called EEG_sub_files. And if we open that up, we can see that we have data files that are labeled like OA01EC, OA01EO, OA02EC, OA02EO, and so on and so forth, all the way down to YA22. If we select all of those, we can see that there's actually 88 items. It's because there's 2 files for a total of 44 participants who are either older adults, those are the OA files, or younger adults, those are the YA files. And these are EEG data that were collected either during eyes closed rest or eyes open rest. So that's the EC and the EO part. If we open up one of those files, we can see that the data file looks like this. So we've got kind of a column of row labels, a column that tells us the frequency of the oscillation, and then a column that tells us the power in the signal at each of those frequencies. So these are the power spectra from an EEG, and if you're not familiar with that, we're going to visualize it a little more in the videos later on to give you a better sense of exactly what that means. But these are all electrodes from different locations on the scalp. So the Fs would be electrodes from the front over kind of the frontal lobe at the front of the head. C is kind of central, so that's moving to kind of that central region over the frontal and parietal lobes. P is going to be parietal. O is going to be occipital. And if you're not familiar with, EEG locations, that's okay. Again, we're going to kind of organize these together a little bit later on. But each subject has the power at each frequency in each electrode. And in this case, this is from a montage where there were 32 total electrodes. So if we scroll down through these data, what you can see is that the power starts to fall off, especially as we start to get into higher frequencies. It basically approaches 0. And after a certain point, due to the filtering of these data, there's actually basically no power in that signal. So there's actually no power once we get up above about 80 hertz or so. But the data file actually goes all the way down. If we keep scrolling, I think it cuts off at about 500 hertz. So these are pretty big data files. Yeah, 510. So there's, 512 rows and 32 columns in each of these data files. And what we're going to be trying to do is organizing all of these individual EEG data files together so that rather than, a big series of 44 individual data files, we have one master data file where all of each subject's EEG data are combined. So this is what we're going to call data wrangling. And data wrangling is sort of the step before having data tidying. So data wrangling is getting your data from kind of rough, disparate formats into a general, pretty workable format. So we want to try to create tidy data from this rough data. And once those data are tidied, then we can do little steps to kind of move the data around into a really task-specific format for a job we want to do. So at this data wrangling stage, our goal is to get the data organized into kind of the most flexible format possible. And then in the subsequent videos, we'll work from that master data file to make really kind of task-specific data formats when we want to create a certain figure or we want to do a certain statistical analysis. But first and foremost, we have to get all of these individual subject data files together. and stitch them into one master data file. So let's go to our script 01 merging data script. Again, you can open this from the scripts folder from the GitHub repository. And once you have this open in RStudio, we're going to go ahead and load the tidyverse library. And then we're going to import the data. So again, you'll have to set the working directory to the kind of correct place on your computer. But in my case, it's in the documents folder under GitHub and then repro rehab. And then let's use the list files function to see what's in there. If you've cloned this repository to your computer, you should see that there's a data subfolder, the README file, and then a script subfolder. Let's look in the data subfolder. There you'll see that there's a processed EEG data file, the subject folder called EEG subfiles, and then a master EEG data file as well. So the process data and the master file are actually where we're going at the end of this video. They're already, in the repository so that you have them. But what we're actually going to do is create this master file from these EEG subject files. And then in a subsequent video, we're actually going to create this processed file. But first, we'll look inside of the subject folder. So this just mimics what we did, visually through the Windows interface earlier. But you can see if we list all the files inside of that EEG subjects folder, we have our 88 CSV files, which relate then to the 44 subjects recorded under the two different conditions. So let's go ahead and set our working directory to this subject files folder, because we're going to want to import all of these subject files. And so we'll work with this file folder as our working directory for now. As an example of what we're going to do, we're going to use the read CSV function that we've done before to import the data for a single subject. So we'll look at OA01 in the eyes closed condition. We're going to save this to a data file called test. And if we look at the head of the test object, you can see that this data frame is 512 observations of 34 variables. Right, the first one called X is actually something we can pretty much ignore because those are just the row numbers. But then we have the frequency in the Hertz column, and then at each electrode across the scalp, we have the power at that frequency. So this is exactly what we were looking at before when we were looking at it in Excel, but now we've just imported one of those subject files into R. In order to import all of these subject files, though, we don't want to just run this over and over again manually, because that means we'd have to run the same piece of code 88 different times. So rather than brute forcing that and really having a very long script file where we have very repetitive code, what we can instead do is create a loop where we have the computer automate what we would ordinarily be doing 88 different times. So we can have the computer loop through each subject file, import it, store it, and then we're going to stitch them all together. So we haven't really worked with loops yet. But the first thing that we're going to do in order to work with this loop is create a list of the things that we want. So I'm going to list all the files in our current working directory, which are the name of each of the subject files, and I'm going to print those to the screen. So I've created this object called file names, and it's a vector, which it's a string vector, which has all of the file names that we're going to want to use, right? Because we're going to want to open up this one and import it into R. Then we're going to want to import this one into R, import this one into R, and so on until we get all the way down to the last one. So we're going to want to loop through each of these file names, and for each one, we're going to want to import those data and then stitch them together. So the first time when I open up OA01, I just want to save that in R. But then once I open up OA01EO, not only do I want to open that into R, I want to add that onto the end of OA01 eyes closed. So it's going to get longer and longer with each additional subject that I open up and add on to my data file. So to see how we can interact with this, let's just look at, if the file name's vector, again, we can use square brackets to subset that vector and look at, for instance, the first element or the 7th element, or, coming to the end, the 88th element that we're ultimately going to want to finish with. And this then is going to be the foundation for the for loop that we're going to write. And a for loop is a piece of code that is going to loop through some sequence a given number of times. And for each instance in that sequence, we're going to perform some operation. So the way to write a for loop in R is you say for, and then you have brackets, and you specify what the sequence is. Or sorry, you have parentheses where you specify what the sequence is. And then inside of the curly brackets, you'll specify what operation you want. So here on line 26, we have a very basic for loop in which I'm saying for I in sequence 1 to 10. So I is just a placeholder. It could be any letter you want. There's nothing special about the letter I. But what I'm saying is I as kind of an increment. So I is very commonly used inside of the for loop. So for I in sequence 1 to 10, print the value of I. So what this will do is it'll go through the first element of my sequence, which will be 1. So I will take the value of 1 and it'll print 1. The loop will then begin again at the beginning, right? And now it'll go through the second element of that sequence. So now I will have a value of 2. So then it should print 2. And it'll keep looping through the numbers in my sequence until it gets to the end, at which point the loop will quit. Because the for loop only goes from the beginning of the sequence to the end of the sequence. So once we hit that final value and I is equal to 10, the loop is going to quit. So if I highlight that line on line 26, I press Control Return or Command Return, you can see down in my console window, it runs my code and it prints 1 the first time through, 2 the second time through, 3 the third time through, and then finally it prints 10 the last time through because it's on the last element of the sequence, and then my loop is done because I've finished the sequence. Similarly, I could now say for name in file names, print name. And like I said, I was just an arbitrary placeholder. It doesn't have to be I. It can be anything we want. So to have it make a little more sense, I'm going to call it name this time. So for each name in the file names list, I want my loop to print the name of that file. If I do that, this runs very quickly because it's a very simple operation to print. I have to scroll back up now. But now our loop has gone 88 times, right? The first time through, it printed the first name. The second time through, it printed the second name. And then the 88th time through, it printed the final file name in our file names list. So to show you one final kind of example loop, let's look at a slightly more complicated piece of code. So now I'm going to create some starter value, and I'm going to say k is equal to 0. So before my loop begins, I'm going to set the value of k equal to 0. Now, for each file in the file names list, I have it do several things. First, it's going to update the value of k. So the first time through, k is equal to k plus 1. Well, on the first time through the loop, k is equal to 0, so k plus 1 is 1. The new value of k will be 1. It's then going to print the file name, and it's going to print the current value of k. So this should give me the first file name, and it should print 1. The second time through, right, k had a value of 1. Now k plus 1 is going to be 2, so the new value of k will be 2. It's going to print the file name, and then it will print k, so it should print 2. So this is basically just creating a counter that runs alongside each of our file names. And you can see in the bottom part of our code here, our counter is working and our file names are working. And it's just incrementing the value of k by 1 while printing the file name on each successive round through the loop. So this is helpful to show the behavior of the for loop and what you're trying to accomplish with it. But it's also really helpful to print things to the screen at different stages in your loop. Because if you ever hit an error by printing kind of where you're at in the loop, that can help you detect where something went wrong. And you can actually say, oh, okay, well, if it went wrong on the 80th file, then I know I have to go and look at YA17. If it went wrong on the 82nd file, I know I have to look at YA18. So by printing within your for loop, that can also be a useful kind of habit because it'll allow you to diagnose problems very easily if you run into other issues. Next, on line 44, we're going to add an if statement because it's going to be important for us to evaluate if certain things are true inside of our for loop. So not only are we going to have the for loop, but we're also going to have an if statement inside of it. So to understand the behavior of an if statement, it's a lot like the for loop. You have if, and then inside of your parentheses, you have it evaluate a certain statement. So in this case, I've said 1 is greater than or equal to 2, and then it will evaluate that as either true or false. Inside of the brackets, you tell R what action you want to take if that evaluates to true. So if 1 is greater than or equal to 2, in this case, I want it to print, oh yeah, to the screen. And that is not true, right? That evaluates to false. So that's going to return nothing down here in my output window. What about file names from our file names vector? So file name number 1 was OA01_EC. So I'm going to say if file names number 1 equals OA01_EC, now print oh yeah to the screen. Well, I mean, we just checked this, so we should know that this is going to be true. But that first part is going to evaluate to true, right? And then it will print oh yeah to the screen. So that was the name of the first file name. Therefore, that condition is true. Therefore, what we put in the curly brackets is going to happen. Now let's try something a little bit different. We'll do file names 1 equals, but we'll say OA with a capital OA. So R is very case sensitive. It's not going to recognize that capital OA is different from lowercase OA. So now what happens when we do that? Well, if, file name equals capital OA, that's going to evaluate to false because our first file name is not capital OA. It is a lowercase OA. So the if statement is going to return a false, and therefore what happened in these square brackets doesn't get executed. So nothing got printed down to the screen down here. So maybe that's not always helpful. Maybe actually if it's false, we want something else to happen. So let's say now if file names equals, OA01 with a capital OA. So now we know that this is going to evaluate to false. If it were true, we'd print oh yeah. Otherwise, we can say add an else statement to say, okay, if it's not true, and therefore if it's false, we can print oh no. So by combining an if with an else, now we can actually print something to the screen in both cases. If the statement in our parentheses evaluates to true, the computer will do what we put in the first set of curly brackets. Otherwise, it's going to do what we put in the second set of curly brackets. So in this case, right, when I run this code, the file name is not capital OA, it's lowercase OA. So the statement in parentheses evaluates to false. Therefore, we skip over the first set of curly brackets and we go to the else statement. Because if this evaluated to true, we do the first thing. It does not, it evaluates to false. So we do else. And in every other situation, then we're going to just print oh no, and therefore oh no gets printed to the screen. So now we can combine this if statement with our for loop in order to read in the individual file names, determine if they've already been read in, and then if it hasn't been read in, what we want to do with it. And if it has been read in, what do we want to do with it? So before we actually run this code, let's just talk through our for loop here on lines 69 to 91. So this looks a little long and it might be a little intimidating at first, but let's talk through each of the parts and just show how we're building up our for loop, where we're going to loop through our file names, and then what we will do each time through the loop. So first, our for loop is going to start the same way that we've done it before, where it's going to look at a name in the file names vector. And the first thing it's going to do is print that name. So this is helpful because down in our console window, it's then going to tell us, where we're at in the process, where we are as we go through this loop. So the first thing it'll do is print the name of the first file to the screen. Next, it's actually going to import that name, right, the file that corresponds to that name, from the CSV file, and it's going to save it in our local environment as subject. So the first time through, it's going to read the name for the first subject and save that as subject in the local environment. Next, it's going to we're going to ask it to evaluate if there exists something called master in the local environment. So if exists master, and we're putting a little exclamation point here before exists to indicate that it is actually a negative, because the first time through we won't have created anything called master. So if I just said exists master, that would evaluate to false because there's not going to be any master object in the local environment. So by putting the exclamation point here, that's the R code for creating a negation with a logical statement. So what I'm actually saying then is if master does not exist, and the first time through, master is not going to exist, so this will evaluate to true, and then it will do what is in the curly brackets. So the first time through, master does not exist, this evaluates to true, and then what we're going to do is create a object called master from the first subject's data, and we're going to create a file ID column within that master data file based on the name of the file. Now, the second time we go through this loop, or actually, sorry, let me say the first time we go through this loop, right, because this is going to evaluate to true, we are going to do what is in the first set of curly brackets, and therefore it'll skip over the else statement, and we'll just go to the end of the loop, and then we'll come back up here to line 69, and our loop is going to start again. And it will now take the name, will take the second value from our file names vector, and it again will print that name of the file to the screen so we can see where we're at in the process. And then it's going to import the data for that subject, right? So it's going to overwrite what was the subject data frame in our environment with the new file. So the first time through, the subject data frame was the data from the first subject file. The second time through, this subject data frame is going to be the data from the second subject file. And now when we come down to our if statement, we'll ask, does master not exist? The first time through, we created the master object, so it's going to exist in our global environment. So this is going to evaluate to false. So the second time through now, we're going to skip this set of curly brackets and we're going to go straight to the else statement. And what that will do is again convert the current subject's data into a data frame that we'll call temp dataset. And we will create a new column within that temp dataset, which we call file ID, which just takes the name of the current file. And then this is where it's really important. We are going to update the value of the master data frame by row binding the master data set to the temporary data set. So the master data set included the first subject's data, and the temporary data set includes the second subject's data. By row binding, we are just adding those on, so we keep all the columns the same. We're just adding the second subject's data as new rows to the end of the first subject's data. So this is going to make our master data frame longer, and we will update that master data frame. And then at the end, we just remove the temporary data set from the local environment, and we're going to go back to the beginning of our loop. So now let's talk this through one more time for kind of the third time through this loop, and then we'll actually run it to see what happens. But the third time through this loop, right, again, it's going to take the third name from our file names vector. It's going to print the name of that file to the screen so that we can see where we're at in the process. It's going to import that third subject's data from the CSV file and store it in the local environment as the data frame called subject. It's going to say if master does not exist, and we created the master object way back in the first time through the loop now. So this is going to evaluate to false, which means we'll skip over this first set of curly brackets and we'll go straight to the else statement. Inside of our else statement again, we're going to create something called temporary data set from the current subject data. We're going to add a file ID column from the current name of the file that we're using. And then we're going to row bind the master data with the temporary data. And now the third time we're going through here, the master data set is going to contain data from the first and second subject. and the temporary data set is going to be the data from the third subject. We're going to row bind those together and update the master data frame to now contain all of the data from the first subject, the second subject, and the third subject, and it's just going to keep growing longer and longer. And our loop will keep running, going through each file name and adding the data to the master data set. So it's just going to add new rows for each subject. And if we've done this correctly, it should do this 88 times until all of the subject's data are added together. So let me go ahead and pull up our console window a little bit higher so you can see it run through this process. But I'm going to go ahead and put my cursor on line 69 of the script file, hit Control Return or Command Return, and you'll see it's going to start printing all of the names for our files from that file names list. And if we scroll all the way back to the beginning, it starts with OA01 eyes closed, then goes to OA01 eyes open, and it's going to finish with the 88th file name, right, being YA22 eyes open. And so now if we look into our local environment, the master data file is 45,056 observations of 35 variables. So this looks like we've pretty much stitched all of our individual subject files together. And we can do a little bit of division to make sure that checks out. So let's come down here to the console window. We'll do 45056 divided by 512. That's equal to 88, right? So we have 88 subjects with 512 rows each. It looks like this is our data frame is the correct length. It has the correct number of rows given our 88 subjects and 512 rows per subject. It also has 35 variables because remember, each individual subject only has 34, but we created this additional file ID column, so we should have one more column than our individual subject files. So it looks like our loop has worked. Our master data file has the right number of rows, and it has the right number of columns. But just to double check, let's print the head of the master data file to the screen. So you can see that it has, it starts again with that just row counter column of X, but then we have the frequency, and in each subsequent column, we have the power in each electrode at that frequency until we finish with this file ID column, which tells us what file that row of data came from. We can also use the tail function, right, kind of the complement of the head function, to look at the tail of the master data and just make sure that we finish with the right file IDs, right? Because if this was still showing like OA01 down here, that would be an error and something would have gone wrong in our loop. But this is ending correctly, right? We know that the final file ID it was supposed to read in was YA22, and YA22EO is the last set of data. And we can see it also finishes at the 510 hertz for that subject. So certainly by looking at the number of rows and the number of columns, and by looking at the head and the tail of the master data frame, it looks like we have successfully stitched all of these data together to create one master file. However, there are some things that we want to improve upon here to try and make this file a little more workable and have some variables that are a little more meaningful. So one thing I would like to do first is actually move this file ID variable to the first column rather than the last column of my data set. So I can do that using the relocate function from the dplyr package. So I will update the value of the master data frame by pushing the master data frame through a pipe into the relocate function. And then if I just give it file ID, the defaults with relocate are that anything you give it, it will move to the front. So everything else is going to stay the same, but this is going to move file ID to the front. Then similarly, I'd also like to drop that X column, which is just counting the rows. So I'm going to say, okay, update the value of the master data frame by pushing the master data frame through a pipe, and then select from the dplyr package allows me to select columns. And if I say select -X, that means it's going to keep everything else, but drop that X column. So if I do that, I can then look at the head of the master data frame, and you can now see that file ID is the first column, X is gone, and then we go into the hertz, and then each electrode still in their original order. So I've successfully moved the file ID column to the front, and I've dropped the X column. Now, having that file ID column is really helpful because it gives us kind of quality assurance that data are coming from the right file. And we want to be able to see, what file those data came from later on in the process. But the file ID actually contains several different pieces of information. First of all, it contains a subject identifier, being like OA01 or YA01. And then it also contains the condition in which the data were collected. So in addition to the file ID, I might like to split that file ID apart into those separate pieces of information. And we can do that using a function called string split. So string split takes several different arguments. The first one is we have to tell it what string we would like to split. So the string we want to split is that file ID column from the master data frame. So we can say master $file ID to isolate that vector of file IDs. And then we have to tell it what character we would like on which we would like to split that string. So this is a really great lesson in why you should have regular variable naming conventions and regular file naming conventions. Because all of my file names go subject ID underscore condition, what I can tell R to do is split that file ID on the underscore. And then it will return the different pieces of that file ID. You can see there's the part before the underscore being OA01, and there's the part after the underscore, which is the EC.CSV. So I've used the square brackets here for a list because the output of the string split function is going to be a list. So it's a double square bracket with a 1 in the middle to just return the first observation if I did this. But you can see, again, then this is our first file name, but it splits it in the right place. It splits it into the subject ID piece, and it splits it into the condition piece. So next, if I didn't want to just do this and print it to the screen, I'll actually have to use the same function and save it to a variable. So the variable we're going to create is called master $subject ID. So we're going to create a new column within the master data frame. And that is going to be based on the exact operation we just did. So at the heart of this, I am going to use the string split function, and I'm going to split my string, which is that vector of file IDs. I'm going to split it on the underscore, again, because I want to chop it up into OA01 and EC for every row. Now, because that is going to create a list of characters, I have to use this map character function. So inside of map character, I'm going to tell it that I want my split string, and then I can tell it which element I want it to pick. Do I want it to take the first element or the second element? And in this case, for the subject ID, that's always going to be the first element because my file names were always subject ID underscore condition. So by using map character, split string, master $file ID, I can split it on the underscore and then take the subject ID piece and get rid of the condition piece. And then finally, I'm going to take that output, and rather than saving it as a character, I want to save it as a factor. And we discussed some of the differences between factors and characters in our previous video on our data types. But if I do that, that's going to save my new variable called subject ID. And now I could say, for instance, summary master $subject ID to get a quick report on my different subject ID variables and how many observations there are for each one. So you can see that I've got my OAs here, right? And 1,024 observations per person. One person does actually seem to be missing data. OA22 doesn't have one set of data. We'll have to see exactly which one, if it's eyes open or eyes closed, in a second. But they only appear to have half of the data of some of the other individuals. Everyone else, though, appears to have 1,024. OA24 also only has 512 So we might have some subjects who are missing data in 2 of the conditions. Everyone else, though, seems to have 1024. But the nice thing is you can see, most importantly, that our split string function has worked, and we've successfully pulled out the subject IDs from our file name. And now saving that as a factor makes it easy to do quality assurance checks, like looking at the number of rows for each person here. Okay, so next we'll do the same thing, but we want to pull out the condition variable. So we can do that using split string, and we'll do the file ID and save that second element. However, if I do that, now let's look at head of master. You can see that condition isn't quite as nice as file ID, because file ID, or the subject ID, was OA01, which is what we want. If I just take the second element from that split string function, though, now I get the condition, eyes closed, which is what I want, but I also get the file extension, which has been added on to the end. So there would be different ways that you could do this. Like you could split this string on the period after splitting the larger string on the underscore, right? There's a lot of different ways you could potentially approach this problem. But what I'd really like for my condition variable is to just have the EC and to drop this .csv. So in order to do that, again, let's look at the behavior of our split string, our string split function. So if I do map character, right, because that's going to help us work through the list. And the characters I want to map are the list that gets returned from split string of my vector of file IDs. And I want to look at the second element that comes out of that split string. You can see all of these have the condition value, right? They're either EC or EO, but they also have .csv. So the other thing that we can do to add on to the outside of this is this string sub, or str sub function. So I'm going to do this on the end. The middle part of my function is going to stay the same. So I'm going to use map character, and I'm going to use string split to split my vector of file IDs on the underscore and take the second element. So this is going to take, the ec.csv or the eo.csv. But now what the string sub command allows me to do is to subset a string on certain points. And so I'll say 1 and 2 as the defaults. But what is implicit here is actually that this is start at 1 and stop at 2. So it's going to start subsetting the string at the first character, and it's going to stop subsetting the string at the second character, which means if this works correctly, I should just take the first 2 characters from each of these elements that is getting returned. And if I do that, oh, whoops, maybe it's not called start and stop. It does not like that. So let's actually look up the help for string sub. Aha, it's called start and end inside of this function, not start and stop. So let me call this start and end. Now when I do that, I get the EO by itself and the EC by itself, just like I wanted. So I'm losing that .csv extension at the end of the file. So now this series of functions seems to be returning what I want. So on line 115 now, let's go ahead and create a new variable, so called condition, inside of the master data frame. And it's going to be exactly the same thing we just did, but again, I'm putting this all inside of the factor function in order to turn all these ECs and EOs into a factor variable that has 2 levels. So again, to walk through what we're doing here, right? Starting in the middle of this, we are splitting our string, which is that vector of file IDs, and we're splitting it on the underscore. Map character is going to allow us to take that list of split strings and take the second element from each one in the list. String sub or string subset is then going to allow us to, within that second element, just take the first 2 characters, because we're going to start on the first one, we're going to end on the second one, so we're just taking the first 2 characters. And then finally, putting all of that inside of the factor function is going to convert that output into a factor. So when we save this condition variable, it's going to be a factor with 2 levels. And we can see that a little more easily if I say summary, master, $ condition, and print that to the screen. Now you can see we have equal numbers of eyes closed and eyes open observations. Again, because we might actually want this to not be at the end of our data file, but at the beginning, I'm going to relocate file ID, subject ID, and condition to be my first 3 columns. And then let's take another look at our data file. Now you can see, okay, within our master file, we've got the file ID, so we always know exactly where a particular row of information came from. We know what subject that belongs to, and we know what condition they're in. And then we know, again, we've got our Hertz column, so that's each frequency, and then each subsequent column is each electrode, and we're looking at the power at each frequency. So this looks good. This looks like what we want in terms of having all of the data stitched together into one master file. So finally, we just want to export this. So I'm going to look at the current working directory by using the get working directory function. And what that returns, right, is that our working directory is still that subject file folder where we had individual subject files. So I actually want to move back a level. I want to go just to the data folder, right? Because I don't want to save this in the individual subject file folder. I want to save this in my data folder. And then I can say write CSV. And the write CSV function takes a couple different arguments, but primarily it takes 2. One, we have to tell it what data frame we want to export or matrix we want to export. It can basically export anything that you can write into a table. And then we want to tell it what file name we want it to have. And it will now write the master data file, the master data frame from the local environment onto our hard drive as master EO and EC EEG.csv. So kind of a long file name, but very descriptive about what it is. And if I say write.csv, I can come back to my Windows Explorer tab, look in the data folder, and now we can see a master EO and EC EEG file, which should have a modified timestamp that matches whenever you just hit write CSV from R. So in subsequent videos, we're going to be working with this data a little bit more to try and show you how we can now take this very workable data set and do a lot of things with it in terms of analysis and data visualization. But this is a critical first step for being able to take all of these disparate individual subject files and stitch them together into one master file.